All right, so talking with Becky here, and I've got a simple question for you. I've got a simple system set up, and I'm going to explain a little bit about, kind of the work Becky does and how she goes about doing it in very simplified terms. And then I'm going to pose a question to you and to Becky, and I want to point out right away, there is no true answer to this question. There is no right or wrong. There are just going to be different interpretations in how you analyze it. And what I want to show is that these are what we would consider a very difficult set of problems to analyze. So if you're reading something in the news and you think, there's got to be a catch or that's probably wrong, there's probably an interpretation where it is wrong or it can be viewed differently. So, and I want to show it in a really simple set of terms. And I'm going to use an animal as an example to show just how tricky these problems can get. So, before I do that, I'm going to explain what's going on a little bit. We've just got 2 farm fields, and they're growing corn on each of them, but they're identical. Everything in these systems are identical, except this one's got a sheep. And at the end of the year, when the farmer's done harvesting his corn, say he loses 1% of the corn on the ground, right? On each of these fields, but one of them he turns a sheep in. So I'm going to set the stage for what's actually occurring as far as carbon emissions. And the easiest one is emissions from the tractor that are going to the atmosphere. And it's the same in both systems. And they originally come from fossil fuels, right? That's the path it takes. You're going to have some soil carbon emissions. We're going to assume in this example that soil carbon is the same this year as it was last year, right? So that means you've got some carbon from the soil leaving to the atmosphere, but it also means you've got the same amount of carbon coming back down from this plant into the soil. And that's the same in both of these scenarios. So we'll set it up the same. And then we've got, on the same in both of these, we've got sequestration going on from the plant. So there's some amount of biomass that's growing in each of these scenarios, and they're the same in both cases, right? Same yield, same tonnage, same biomass, same machinery, everything's the same. But each one of these loses 1%, gets left on the ground. And on one field, the farmer decided to turn a sheep in. And that sheep has emissions, right? It's going to eat parts of this plant. He's done harvesting, it lays on the ground. The sheep comes in, eats part of it. And then it's emitted, right? That's emitted back to the atmosphere. Now, you also get breakdown when, say, worms, microbes digest this plant material. That's going to go to the ground or go to the soil surface. It's going to get broken down. Essentially, all that's going to go back to the atmosphere. Most of that litter that gets dropped on the soil surface will eventually be respirated by some organism. So the rest of it's going to be respirated. And the same is true here. That plant material ends up being decomposed and respirated. So the question is, in this scenario, in this one, 100% of that plant material is being respirated, right? It's being turned back into CO2. And the same scenario is here, except some of it's making a pit stop through sheep. So here's the question for you, Becky, and for anyone else who's watching this. If you're doing this analysis, do you put those carbon emissions from this sheep, do you attribute it to the sheep, or do you attribute it to the corn?
Well, I suppose it depends on what you're trying to do. So it originates from the corn, and it goes into the sheep, and a fraction of that goes from the sheep to the atmosphere and respiration.
Yeah.
So that's like asking if a human being eats corn,
Yep.
and they breathe some CO2 out, is that emissions from the corn or from the human being?
Right. And that's actually a complicated question, because I'm going to make the very simple argument that I would attribute it to the corn, because this is actually a waste product of this thing. The sheep essentially had no bearing on how much is emitted. In this scenario, you still have just as much CO2 emitted, but you're actually producing less, less food for humans to eat. But the sheep is just a stopping point. We can do something useful with the waste product. And that's where it gets complicated, because that's not really the correct answer either. You know, you could say it's the sheep's emissions, right? And that would be perfectly reasonable. But it would also be perfectly reasonable to say it's attributed to the corn.
If you're interested in a corn ecosystem
Yeah.
and all of the sources and sinks of carbon, then I think your analysis would be most fitting.
Yeah. And see, that's, you know, that's where these things get really complicated, because this is a very simple system, and this only gets more complicated from here on out. And there is no true right or wrong answer. There's just really a difference in how you account for it. I just wanted to show that to everybody.
Yeah, yeah, and it illustrates, makes it easy in a sense, because you're bringing it back down to the basic raw beginnings, which is photosynthesis into the plant, and that carbon originates from there, and emissions are all just different pathways. And I think that's right on, putting the sheep or any animal as an intermediary, a stopping point.
So that's something to think about, because this, you can expound on this. It's a very simple system. You can expand it, and things only get more complicated. So when you read something, you know, a scientific article or whatever it might be, think about what they actually analyzed and how they analyzed it. And if you don't know, you know, ask somebody. You know, there's absolutely nothing wrong with that, because this is really complicated. That was just a brief example of how this works.
And a great way to bring up the topic about something that can be debated, you know, and look at the numbers and make it real interesting.
Right.
Well, thank you so very much.